Hello, now we'll go with nitration on benzene. You can consider this as electrophilic aromatic substitution. This is one interesting and little important because here what is the electrophile, what is the role of HNO3, what is the role of H2SO4, what happens if the temperature is more than 60 degrees Celsius or even at higher temperatures. All these are the questions possible. So first let us go with the equation. It is the benzene when treated with concentrated HNO3 and concentrated H2SO4 and mandatory conditions below 60 degrees Celsius. Then the product is nitrobenzene. Actually, H will be there, H2O out. You can show like this. Benzene when treated with concentrated HNO3 and concentrated H2SO4 1:1 by volume ratio below 60 degrees Celsius, then nitrobenzene is formed. This compound is nitrobenzene. So what are the things that can be asked? At what points you must be very careful. Just have a look here. Concentrated HNO3 and concentrated H2SO4 when you are taking, what is the electrophile and how it is generated? The electrophile is NO2 plus and HSO4 minus plus H3O plus. This is the equation that you are getting. The electrophile is NO2 plus. The first question that they can ask you is what is the role of H2SO4? H2SO4 is losing its proton, so it is acid. What is the role of HNO3? It is functioning like a base. Interesting, but it is a fact here. Okay, HNO3 is a base in this reaction, so this is your first question. In nitration, how HNO3 functions, how HNO3 acts. HNO3 is a base here. H2SO4 is an acid. It is losing proton, it is accepting proton, and it's converting into NO2 plus. NO2 plus is the electrophile. So once the electrophile is generated, the reaction will be very simple. It is dibenzene. When NO2 plus is coming, the electron, pi bonded electrons in the benzene ring are attracted towards this. You can add any of these two positions. If you are adding here NO2, already one hydrogen will be there. Here one hydrogen will be there. Because of this electron pair is shifted here, you are getting plus charge here. This is called a resonance stable system. In this resonance stability is there, you can shift this electron pair here, you can shift the electron pair here. So this is going to be stable. That's why it is possible, but it has lost its aromaticity. There is no aromaticity now in this compound, but there is resonance. Next point is, okay, now we are not writing all the resonance structures here. Next point is this hydrogen is lost in the form of proton and this electron pair is coming back. So you are getting this double bond, and this is the double bond. This hydrogen is as it is, I am not touching this one, and you got here NO2. A hydrogen from here is replaced by NO2 group. That's why this is called substitution on aromatic ring by an electrophile. So you can say electrophilic aromatic substitution reactions. It's about nitration. Then another question, what happens if you are having a temperature more than 60 degrees Celsius? More than 60 degrees Celsius means there is a possibility of getting second time nitration on already nitrated benzene. That means if already nitrobenzene is there, let us say NO2 group is there, again if NO2 plus is going to attack, this is possible when you are doing at more than what we mentioned temperature 60 degrees Celsius. This is NO2 group and NO2 group is coming here. Fine. Why it is going to this place only? That is the most important line. So see here, if this is the case, NO2 will be like this. NO2 is called electron withdrawing group. This is a minus I group as well as minus M group, mesomeric, negative mesomeric effect. Electron pair is shifted this side. This electron pair is shifting here. So you will be getting this double bond N, and this is dative bond. This is oxygen with negative charge, plus charge here. Ortho position, you can see plus charge is there. Now it is again stabilized by this one. So you can see here plus charge is at para position 2, one more structure you can keep here, and there in that case also you are getting the plus charge at ortho position. So you wanted to add an electrophile. Already positive charge is present at ortho and para position. So when already positive charge is there in the benzene ring, the positive charge group cannot attack on that place. So at ortho position, at para position, it is impossible to attack. So where it will go? The remaining position, remaining available position is only meta. This is ortho, plus charge. A plus charge cannot attack on this. It is para, it is plus charge, so it cannot attack on this. So the remaining position is this. That's why when you are doing nitration, it will go here. Or if you have one more, for example, this is NO2 group. So to this, don't generally students ask this one, sir. This is the position. Where is meta? Generally they think that this is the meta. This is not meta. With respect to this third place, it is first place. This is second place. This is third place. So here NO2 group is there. And if you are again going for nitration, NO2 plus, again it will come at this point. This is already meta out toward from this side meta, from this side meta. So the nitro group will come here. So this is the nitration on benzene and nitrobenzene. If it is not nitrobenzene, if it is some other group like phenol or NH2 group, what generally happens? Okay, so about that also we'll discuss. Exclusively we are discussing about nitration. Let us go with a methyl group. Toluene I am taking, and if you are going for nitration, I am not taking concentrated HNO3 H2SO4 60 degrees Celsius. I am just mentioning NO2 plus. You have to consider that the HNO3 and H2SO4 are always taken. Now this is called OP director, ortho and para director. So you can expect this at this place as well as this place. So generally student ask you which is more stable or which is major. This is the major one. Para is always major unless it is having a hydrogen bond. Intramolecular hydrogen bond you can see in this between them. Then you can expect that is most possible. See this one. If I am taking on phenol, NO2 plus, okay now. You can if you are taking HNO3 and H2SO4 at lower temperatures like that, not very concentrated, then NO2 plus will come at ortho position. Interestingly, between them you can expect a dative, a hydrogen bond you can expect between them. Right? This is a dative bond and a hydrogen bond you can expect here. That's why this is going to be major. Ortho major here, and of course you can get here para. Because this is ortho para director, as I said, it is also ortho para director. OH group is also ortho para director. And if you are using OH and concentrated HNO3, that means if NO3 concentration is more NO2 groups are coming, then you are getting one very special compound, NO2 this place, and NO2 here. Surprisingly, this compound is given a name as picric acid. There is no COH group, even though it is called acid. So it's a respect to this compound that it is highly acidic, because the phenoxide ion after losing this proton is highly stabilized by 3 NO2 groups, 3 electron withdrawing groups. So this is a very good acid having low pKa, higher Ka, and you can say one of the strong acids, organic category. Okay, organic acids are only weak. In that it is one of the strong acids. In the weak acids it is good, organic wise. So all these what we are discussing are ortho-para directing groups. Okay, but you must be very careful if you are having NH2 type of group, because if NH2 group is there on benzene, NH2 group is going to be a base. Okay, and it is not a strong base, but it's a base. So if you are using concentrated HNO3, there is a possibility of getting this compound. Concentrated HNO3 if we are using, this is also ortho-para directing group. So NH2, NO2 here, NH2, NO2 here. These two you expect, but interestingly, surprisingly, you are getting here NH2, NO2 also. This was a question asked recently in IIT entrance examinations, I think. So how you are getting NO2 at this place? It's again very simple. You see, as I told you, NH2 is a base, and you are using here concentrated HNO3, which is an acid. So acid first reacts with this base to form NH3 plus. Once NH3 plus is formed, this is now, it is orthopara directing group, OP, but this is a meta director because it is not having any electrons. It is a meta director, and because of this, you are getting there a meta nitro group. Normally, NH2 group if you are taking, of course, these two possibilities are however there, but considerable amount, approximately around 40 to 40, almost 50%, 47% like that, you are getting this compound. So be careful while doing this reaction. Okay. Of course, in the laboratory also you are getting there more than one product, and in examinations also you must be very careful about this. Then what you can do generally, if you want to avoid this reaction, you need to protect this group. That's called protection. For protection purpose, what we do is, it is treated with CH3COCl, acetyl chloride. When you are using acetyl chloride, this will become NHCOCH3. Now this lone pair is in association or in attraction with this one. So if you are doing now nitration, nothing will happen. The NO2 group will be located at this ortho position or para position only. It won't go to meta position because this electron pair is now not active. That will be always in resonance with this CO group. Okay, now how it is going to be? C double bond O. You can expect here. Again, this is hydrogen. The pair is coming here. The electron pair is moving here. So such kind of resonance you can expect. And if you want to get only an orthopara, you must protect this NH2 group. You must lock this NH2 group, and NH2 group lock or protection is generally done by this. Okay, so these are few questions about nitration. Thank you.